So number 5, on the worksheet that I gave you. There's a lot going on in this problem, so let's talk about it. Methane is produced in a cave at that rate in liters per hour at time t hours. The initial amount of methane in the cave at time 0 is 20. At time 8, a pump begins to remove methane at a constant rate of 1.5 liters per hour. All right, so let's get a visual of what's happening here. We got a cave, it's got some methane in it, and methane's being produced at a certain rate for this total amount of time, but at time 8, a piece of equipment is going to come in and begin removing it. Okay, so question A says, at what time t during the time interval 0 to 8 hours is the amount of methane increasing most rapidly? Increasing most rapidly. What am I looking for? Yes, sir? Oh, no, I'm not in any sort of logistic growth here. That would have to be a logistic growth equation, and I don't have
that. You're looking for your values, the derivative equal to 0, critical point.
I'm looking for where R of t is a max, right? Because R of t is my rate, and I want to know where the rate is increasing most rapidly. So I need to know where R of t is a max. So somebody in third period said, well, graph R of t and find the max. Well, for AP Calculus, they want you to use calculus to solve the problem, not pre-calculus to solve the problem. So R of t would have a max where what is happening? Very good. Where R prime of t changes from positive to negative, right? Where it's equal to 0 and change from positive to negative. So I need to set R prime of t equal to 0. This would be a calculator question on the AP test. So, and then here's another thing that I would do if I were you. We're going to use this equation over and over again in all of these questions. So if it were me, I would enter R of t in my calculator. Okay, and I put that in Y1. And then I'm looking for where R prime of t is equal to 0, right? Sorry, I know that's hard to see. So I'm going to go ahead and graph the derivative so I can see where R prime of t is equal to 0. So here's my R of t. Make sure for the fraction that you've got your x with your pi, so it does order of operations correctly. And then to graph a derivative, remember that you go to Math 8 if you're working on this calculator. And if you're on an Inspire, go to the calculus. Okay? And then I took the derivative of what was in Y1, so remember you can pull that up using alpha trace. And so it's Y1. Oh, shoot. Sorry, I'll just do the whole thing then. Math 8, doing it with respect to x, doing it for what's in Y1. And remember that your calculator can graph a derivative for all x if you tell it that. So you're going to graph the derivative for all x, yes.
Isn't R already a rate?
Yes, but it says where is the rate increasing most rapidly?
The highest rate of the rate.
Correct.
Okay.
Okay, so it wants to know when is the amount of methane increasing most rapidly? So the equation that I was given is the increase equation, but I want to know where it's increasing most rapidly, so I need the max of R of t. So I need to know where R prime of t is equal to 0 and then changes from positive to negative. So a good window would be 0 to 8, right? It wants it over time 8. And then I just made my y values go negative 10 to 10.
delta x always gets messed up. They're like
ocean waves, not like regular.
On this screen?
yeah, the delta x it always goes to weird numbers.
Does it say X scale? I don't have a delta X.
No. Oh, I think it's just not on your screen. Yeah. I don't know if that matters.
Oh, I don't know. I don't ever mess with that. My change in X? Nah, I'm not gonna worry about that.
0, 1, 10, 10, 1, 1.
I mean, you could tell it to go by 0.1 or whatever if you want. I don't think it's a huge deal. Okay, so now, if I look at the graph, the first thing that's graphing is R of t over the 8-hour interval. So that's my rate. So I'm looking for where my rate is a max, right? Well, it appears that it's right there because that's its highest point, and that should correspond with a derivative of, hello? Uh-huh.
We wanted to know if y'all wanted to take your picture for the I Heart CHS poster that we did last year, where everyone puts their hands up like this.
Yeah.
Sure.
Okay.
Alright, go ahead. You just need
Go
one of your
quick. You probably need your heart to be around that calculus book, I'm just saying.
I just.
That's any calculation.
Okay,
Yeah.
all right.
Do you want to hold the calculator?
No, I don't want to hold a
Standards?
calculus book. But go. Get. Well, here, we gotta go fast. We got lessons to do.
Big. Tim's just. You're such a lazy.
Here, put your little heart in.
Everybody's got to put their hands up.
Oh, good, I like your big heart.
I got you.
Oh, nice.
Oh, and you're
Guys got to inspire confidence.
Oh, no.
Come on, figure this out.
Okay. Ready? 1, 2, 3. Perfect.
Thank you. Okay, so again, the max on R of t should correspond with where the derivative is equal to 0 and changes from positive to negative, and you can see that it does. There it is, right there, right? Okay, so now I need to find out what that value is. So I'm going to go second calc, and I'm going to wipe the screen off my calculator, and I'm going to figure out the 0. And you'll need to make sure that you're on the right curve whenever you're asking it to find the 0 for you. And what you find is that is when t is equal to 2. Okay? And it does say, well, it doesn't really say to justify your answer, but no, we need to. Okay, R prime changes from positive to negative, therefore, we're at t equals 2, therefore 2 t equals 2 is a max. Okay, B. What is the total amount of methane in the cave at time 8?
The integral.
Okay, what plus the integral?
20.
20, right? Because that's my initial amount. 20 plus the integral from 0 to 8 of R of t dt. Okay, so remember our calculator trick here. R of t is in my y1, right? So from my home screen, I'm going to say 20 plus the integral from 0 to 8 of what is in y1 with respect to x. So how much is in there at time 8?
30.129.
129 liters, right? We good there? Are my Inspire people okay?
Yeah.
Okay. C, what is the average rate of methane accumulation in the cave over the time interval 0 to 24? What is the average rate of accumulation? What have I been given? Rate of accumulation, right? In my initial problem, all that information that I was given, that was a rate of change and accumulation. And I want the average rate of change and accumulation. So what formula am I using? 1 over b minus a integral a to b of f of x dx, right? So I'm going to have 1 over 24. Now this is where it gets a little,
That does not look like an
Oh,
apple.
because of the other one.
because there's more to it, right? We only did, in part B, we only considered what was happening up until time 8.
So we need to.
So now I got to consider what's happening from 8 to 24. Does the 20 factor into this?
No, because there's
No.
0.
Because the 20 is what I had, right? This is asking me for accumulation. So the 20 is like what I started with. It doesn't come into play here.
How
Yes,
come we can't just do the integral from 1 to 24 of RTDT?
I'm about to, but I'm going to do it from 0 to 24, not 1.
Yeah.
Okay, so I'm going to go from 0 to 24 of R of t dt, but something started happening at time 8. Oh, the pump. Minus 1.5 times, what is the time? Yes, Skylar, how'd you come up with that? 24 minus 8.
Why is it 1.5?
Because they told me that. They said
Oh, okay.
at time 8, a pump begins to remove methane at a constant rate of 1.5 liters per hour.
And since there's 16 hours left. Okay.
Right. So this is over a 24-hour time period. It doesn't start happening till time 8. So this is my total rate of change and accumulation, right? And then I would need to divide it by 24 to get the average. All right. So again, just so in case you don't know this, you guys know that you can hit second entry and pull up whatever you just had in your calculator. So I can arrow over here and I can delete what I need to. And then I can insert. Do you guys know how to insert? So I inserted that 1 over 24.
Second reading.
And then I'm going to change my 8 to 24. And then I just need to add to it, right? So there's the 1/24th. And then inside I've got the integral from 0 to 24 of what's in y1 minus 1.5 times 16 and close off my parentheses. And it's thinking. Okay, and what are the units on that value? Liters per hour. And does it say anything else? Nope, that's it. That's my average rate of change in methane accumulation. And I'm going to run out of time for the most important part.
1 minute.
D says, what is the absolute maximum amount of methane in the cave over the time interval 0 to 24? Okay, so I need the absolute max. Absolute max occur where?
Endpoints and critical.
Endpoints and critical points, right? How do you find critical points? I set the derivative equal to 0. The derivative of what?
The rate of accumulation.
He gave us.
Wait,
The derivative.
I need an equation that would describe the amount at any time t, right?
yeah.
Because it's the derivative of that that would give me my critical points. So let me talk you through. So my amount at any time t is going to be equal to the 20 that I started with. Now I'm going to separate this next integral, and I'm going to go from 0 to 8 of r of t dt, because that's a constant thing, right? And then I would add to that anything from 8 on. Oops, that's not a square root. No idea where that square root appears on my paper. That is so not a square root. It's just r of t. I'm sorry, I know that you're late.
No.
Go, hurry, hurry, hurry. See, this is on YouTube. This is why I don't want to be on YouTube. R of x dx minus 1.5t.
Yeah. Sanders account.
1.5t.
But what if it's under 8?
Good question. The better way to write it is probably as a piecewise function. We're making some assumptions here, right? That we're dealing with time after 8. Okay, and that's all I'm gonna have time to talk this long.
We're gonna stop recording.
Okay.
Yeah,
Stop recording. Stop recording.
Sanders, you decided that part out.
Oh my God. Stop.